going to be hopefully a short video on making your printer, your A8 or A6, a lot stiffer by using aluminum angle iron from the big box store rather than printing a bunch of stuff. And if you're pretty good at layout and fab, you can do this just about as fast as you can do the printed versions, which are okay, but they're not going to be as stiff as these guys. First of all, some word about the material. This stuff, as I said, is 1.5 by 1.5 by I think 60 thousandths. And when you pull it out of the bin, be sure to sight down and choose your pieces and leave the bent ones for someone that's doing something not as critical as you are. And make sure you get a straight one. Also, the angle of these guys, the included angle, is supposed to be 90 degrees, but it's not always. So when you cut your blanks for your parts to length, you're going to have to set them down and take a clamp. This is a baby version of what you're going to need. And go over it and give them a squeeze along their length, opening them up, or maybe turning them up this way and closing them up until you tweak that dude at a right angle all the way down. I used my chop saw to check them, the base of the chop saw to check them, which has got a 90-degree fence. But you can do a decent job by just using a speed square. That's good enough. Oh, and a flat surface, of course. Alright, let's talk about the flat surface, which is what you're making all these brackets for. This material is a piece of industrial countertop. It comes laminated on both sides just like this. This piece I've had for a long time. I don't know where the heck it come from. It's been used by other stuff before I got it, and also I've used it for a couple of other things too. This is where the printer was located before I realized that I couldn't have it there. It needed to be turned around the other way. This, I think, has done, this, because it was set on a concrete floor and absorbed moisture, focus, like this stuff is wont to do, and swollen up a little bit here. That's why I have these marks. I'm going to cut that part off, and once I cut it off, I might put this T-strip back. You have to route a groove to put the T-strip in. But before I would do that, I'd paint this edge with an oil-based paint. Not a water-based paint. You don't want it to swell. An oil-based paint to seal it up, and this swelling stuff won't happen again. That, and also, not putting it in a damp place. It is sitting on 3 little cork feet that I cut off of a wine bottle cork. Yeah, it's tragic. You have to drink a bottle of wine to do this. And that makes sure, because it's a 3-point suspension, like that, that this does not pick up any shape from the underlying table. Now, this table, it probably would not, because it's a massive steel drawing table from the 60s. And this is what it was setting on. And being steel, and it acted as a sounding board and made the printer a lot louder than it would be otherwise. They're a bunch quieter setting on these feet. Maybe not so much quieter when you're right up in it, but it doesn't transmit the sound into whatever it's sitting on, which at a distance makes it louder, I guess. So we've got to cover the screws. Now, you want to use something with a small root and a big flute. And definitely something with a pan head. Don't be tempted to use drywall screws. No, no, no. They have a countersink head, and when they go in holes, they will not only bend a dish in this and it won't be down tight, they will also locate to the center of the hole they're in. And you may not have that hole sit perfectly in the right places. It might be a thousandths off this way or that way. I mean, who can drill this stuff that accurately, particularly freehand? And you don't want to put to bend or diagonal the shape of your printer. You want to hold it straight down and not sideways. So you might even use something like this. This is a washer head screw, and if you're a IT kind of guy and all, or a RF dude, you probably recognize these as rack screws. GE, Ericsson, Harris still uses these. And if you drill a clearance hole over the flutes, then this area right up here is a little bit smaller than that big washer head. Lets you drill a hole a little larger if you need to, and it'll still work fine. You can dig these up in the assorted screw, something similar to it, in the assorted screws at your local hardware store. Just don't use countersunk screws. Is mainly what I'm getting at. Okay, let's see. What's the next thing I want to cover? Let's look at the shape of this deal here. You want to use this. Take these plates, this front plate off, and use it as a template to lay this out. Now, some of the measurements, some of the locations you're going to have to measure, because there's no way in the world you're going to draw a circle that's 8 millimeters in diameter and guess anywhere near accurately enough the center of it. You're really going to have to use your vernier calipers. You have a set of these, right? To determine where the center of that hole is off the bottom of the angle. Measure the diameter of the hole, half the diameter of the hole, measure from the bottom of the foot to the bottom of the hole, add the half measurement, scratch it, that's your center. And then you get the idea. You can cut these curves if you have, I just used a nibbler and a file. It goes really, really quickly. I actually nibbled it a little bit, zip, 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 with my chop saw, and then cut it off. And then I used a nibbler tool. I don't have mine handy. It's in a bag that's on the other side of the room. Otherwise, I'd show it to you to make these curves. And also right under here, there's a little nibble that lets the rod not touch this aluminum, and a little tiny nibble for the screw head right here. And then there's a couple of more screw heads in the center here. You don't absolutely have to have these, but I found a couple of SAE screws that self-threaded into the acrylic really nicely, so I just used them. One thing that's important to doing this sort of deal is this particular tensioner, which is probably the best one on Thingiverse. The original version of this, and I think it was made for an A6, was done by a guy whose handle is Gear Down for What. He's got a lot of neat stuff on there. And someone else then remixed it for an A8. It has the advantage of it only uses 2 holes in the normal square, and the ones that use all 4 and then have that upward turn of the roller, they jam in the holes and are really sticky. This one isn't. This one doesn't. And the screw is directly in line with the center line of the belt. And you can take this and actually get the belt way too tight. I think I had it way too tight. You really need to remember to back it off when you're not using it, and then bring it up, and then just get used to what it sounds like when it's right. Okay, that's the front bracket, and then we have these guys under here. This is a spare one I made. So you want the fit to be like this. Make this thing focus. Needs so much light to make it focus right. Anyway, so see how that fits? I'm quite proud of that. Now you don't need, in my humble opinion, any kind of bar across here. This piece here is just in compression and tension. It doesn't really see any forward and backward, and once you put these guys in and screw it down, it's not going to move anyway, so putting a piece across there is just a waste of time, in my humble opinion. I notice these brackets have only have 2 holes, and they're spaced over so you can get by the rod. This one is 2 also. I've only ever used just one of them, but it has two there. You know, if you feel froggy, you can do it that way. Now, since this is an A8, we'll get back to these rods shortly, but for an A6, what you need to see is on the back. Now, I made this back part out of a scrap of aluminum that I cut off of an attic ladder just because I had it handy and I didn't have enough of this in the right size. I didn't have any of this in the right size. What you need for the back is 1x1 angle. And that actually means that when that angle is flush with the top of these cutouts, it doesn't come all the way down to the table, and you want that. You want the machine sitting on its feet everywhere. You don't want it touching this aluminum to touch anywhere. I can't say that about the molded, the 3D printed ones. They don't have that consideration, because you want the machine to register on its own feet. If there's a slight curve in the board, it will pick the machine up, and you definitely don't want that. The back mounts are the same as the front mounts, and I can't get a good angle on them. Anyway, you can see them down in there. It's the same tabs. It's the same tabs right there, and you just drill down and you put a screw in it right there. That gets them away from this bar. So what you do, and I made this up out of the scrap and put this and riveted this together. Focus, finally. So I made this up out of the scraps, as I said, and I did that because I did not want to go to the store and buy more angle iron. I just wanted to get this done. So what I did was I epoxied these three pieces together accurately, pop riveted together, and that gave me one piece that's the length of this, my strong back right dead where it needed to be, and it was just easier. So what you would do would cut one length of 1 inch angle that would go the whole length of the back, and another shorter length that would go from face this cutout to right here across the top here, and then cut this flange down on the top, obviously before you connect it to this, on the top, so the bed will clear it when it comes over the top. And it's held on by the former cover cap screws here and here, motor screw there, motor screw down here, the right under there, you barely can't see it, there's a little drill ding in the plate to clear the micro switch bracket, the bottom screw for the ends, and the rods. This makes the back of this, and this is probably the best thing about this, doing it this way makes the back of this frame unbelievably stiff. Now the front, because it doesn't have this strong arm right across the center of it, is not as stiff, but I think it's good enough for now. I might later go back and add a stiffener or redesign that, but it's good enough for now. Now let's look at the sides. Oh, actually let's look at the other side. So this thing is so stiff I can just grab it in one place and twist it around and not fear about it snapping the acrylic. Let's look at this side, because that's where the board, the control board is, and you can see it better than on the power supply side. So on an A6, I would say this really isn't necessary. But if you want to get crazy and do it, hey, more power to you. So this is a stick of 1.5 by 1.5, and it's cut. It's cut about a millimeter or so shorter than the distance between the tabletop and underneath here, because again, you don't want the machine, the aluminum being the machine's table leg. You want the original legs to touch the ground, or the ground, the countertop. And it's got 3 screws at the top here and 2 down at the bottom. And these screws are just spaced center of this flange and down from the top the same distance. 1 here, 2 here. They come out the front. You know, you can't really see them behind the bar there, can you? There's one peeking over the top. And I still needed to retain the original location of the Z-switch for now. So where the Z-switch slot is, I just marked the slot out and drilled a row of holes because I wasn't sure exactly which one I needed to use. Actually, this makes the Z-switch a lot easier to use because you pick the hole in the range you need over here and then only move this side. It makes adjusting the switch a lot easier, but eventually I'm going to move them over here like most folks do. The down the bottom is the same way, bolt here, and then in the rest of the locations, these are the motor mount bolts, screws going through. The way I transferred those, all the ones that don't have holes, existing holes, I put those in the metal first, clamp the metal onto the machine like this, and then use the metal as a guide to drill these holes. And then you can temporarily screw it on and then transfer these holes through locations through the other way. You can use transfer punches, or one tricky way I like to do that is to roll the blue tape or the aluminum high vac tape, which I like to use, around your drill bit, leaving just a tip sticking out, and make that drill bit big enough that it will fit tightly in the hole. Of course, the drill bit will be a size or 2 under, and you'll roll the tape on it so it'll fit in the hole. And then you can just, once you got this this piece here clamped and screwed or clamped and screwed, I screwed it in place and took the clamps off, transfer those holes through, and then you have the marks, and you take this off and then go drill them the right size. One thing you notice is because the board was originally up here, and since it's flush to the front of this acrylic piece, it wouldn't fit anymore, so I had to drop it down. So I just dropped it on down because I needed just evenly spaced bolts here and here, and then the board's screw makes the next evenly spaced bolt, and then the last one right here is one of the second bolts in this corner, like it is at the top up here. And that's how I got those guys on. Now, if you got an A6, you could say that this would be overkill, and you might actually be right. But another way of putting those on, and this might be better to do on an A6, I think, is to use this 3M super mounting tape. If you haven't ever used this stuff, it is amazingly strong, and they use it in a lot of commercial applications. I've heard they even put skin on aircraft with this these days. I'm not sure whether that's true or not. But all the cars you have out there have body trim and all held on with this stuff, and it's amazingly strong. And there's a variation of this tape that's actually holds the windows in cars now, the windscreen and the back glass. You want the thin version of it, and I'm not sure this is the roll that's the thin version. There's a various thick. You want the thin version for this operation. Now, don't be tempted to just put this tape down the whole face of the angles, peel it off, and stick it in there. Don't do that. Put space tape. My experience would tell me to put a piece of tape across the flange and skip about 2 tape widths, and then put another one into about 2 tape widths, and put another one 2 tape widths, and put another one. And when you apply it, be very, very careful, because wherever you put it, that's where it's going to stay. And of course, you need to wipe all the surfaces down with alcohol to get any oil residue, especially off that metal. The way it comes in the factory, it obviously has an oily film on it, and that will stick it down like nobody's business. I chose not to do that on this guy because of the limited area you have up here. I figured bolts was probably a better thing and kind of the limited area you have down here. But if you were going to try this on an A6, and like I said, I don't know whether it's worthwhile, you can use the tape. Or you can always drill holes later, or I would mark the holes on the stick first, on this first, and then tape it on there so I'd have the marks to drill later if I decided that this wasn't stiff enough. Anyway, so this is the printer I printed that calibration cube that I thought was just damn near perfect, if I do say so myself, that I posted a few days ago. And the sides were so clean you could clearly see the connection of the infill through it. In fact, the next thing you would have to do is go in Cura and tweak the infill to see if you could get rid of that, which is kind of getting way out there. But anyway, there it is, and I'm calling it the Ghetto Plastic Blaster, because I've sort of ghettoed it up with all this aluminum. And some of y'all will get the reference there. So I hope that's inspired some folks, and if you try this, post some pics. We all want to see what you did later.